So here is our example. X minus 2y plus z equals 0, 2x plus y minus 3z equals 5, and 4x minus 7y plus z equals negative 1. So we will solve this linear system and find the values for x, y, and z using Gaussian elimination method. So first, we need to transform this linear system into augmented matrix form. So here is the augmented matrix form of this linear system. So our goal in this topic is to eliminate the upper triangular, which is these three numbers, into 0, and the diagonal entries should be equal to 1. So for us to do that, we will using the elementary row operations. So first, we have to eliminate these two numbers. Sorry, we need to label these three rows R1. So we will eliminate these two numbers, the 2 and 4. So we have this formula, negative 2 R1 plus R2 for the new values for row number 2, and negative 4 R1 plus R3 for the new values for R3. So by substituting the values, so we have negative 2 multiplied by R1, which is 1, so we have negative 2 plus R2, which is 2, so we have 0. Next, negative 2 multiplied by R1, which is negative 2, plus R2, which is 1, so we have 5. Next, negative 2 multiplied by R1, which is 1, so negative 2, plus negative 3, so we have negative 5. Last, negative 2 multiplied by R1, which is 0, so 0, plus 5, so we have 5. Next, negative 4 multiplied by R1, which is 1, so negative 4 plus 4, we have 0. Negative 4 multiplied by R1, which is negative 2, so we have positive 8, plus R3, which is negative 7, so we have 1. Next, negative 4 multiplied by R1, which is 1, plus R3, which is 1, so we have 3. And last, negative 4 multiplied by R1, which is 0, so this is 0, plus R3, which is negative 1, so we have negative 1. Next, we have this formula for R2, which is 1 over 5 R2 for the new values for R2. So we have copy 1, negative 2, 1, 0. So we have 1 over 5 multiplied by R2, which is 0, so we have 0. 1 over 5 multiplied by R2, which is 5, so we have 1. 1 over 5 multiplied by negative 5, so we have negative 1. And last, negative 5 times R2, which is 5, so we have 1. Copy. Next, we have here formula for R3, which is negative R3 plus R2 for the new values for R3. So we will get negative R3, which is 0, plus R2, which is 0, so we have 0. Next, negative R3, which is 1, so we have negative 1, plus R2, which is 1, so we have 0. Next, negative R3, which is negative multiplied by negative 3, so we have positive 3, plus negative 1, so we have 2. And next, negative R3, which is negative multiplied by negative 1, so we have positive 1, plus R2, which is 1, so we have 2. And last, we have this formula for R3, 1 over 2 R3 for new values for R3. So we have 1/2 multiplied by 0, which is R3, so we have 0. So 1/2 again multiplied by 0, so we have 0. 1/2 R3, which is 2, so we have 1. And also 1/2 multiplied by 2, so we have 1. Since we have this upper triangular and the diagonal entries is equal to 1, so we can get the values for x, y, and z. So we have x minus 2y plus z equals 0, y minus z equals 1, z is equals to 1. So for us to, since we have this value for z, so we can get the value for y and x performing the back substitution. So we have y equals 1 plus z, which is 1 plus 1. So our y is equals to 2. And last, we have x is equals to 2y minus z, which is 2 multiplied by 2 minus 1, so we have 3 for x.